4, 2. Empirical law. The probability that a random variable is less or equal to x is denoted as A. The probability that a random variable is less or equal to x1 is denoted as A1. The probability that a random variable is greater than x2 is denoted as A2. The probability that a random variable is between x1 and x2 is denoted as A1, 2. What is the area between mu minus sigma and mu plus sigma? It turns out that this area does not depend neither on mu nor on sigma. Why? Because if we change mu, then the entire graph moves to the left or to the right. If we change sigma, the graph will be squeezed in the horizontal direction and starched in the vertical direction, or vice versa. Let us calculate this area with the help of Book 4, see the link in the description to the video. For example, if mu is 5 and sigma is 2, then x1 is 3, x2 is 7, and a1, 2 is 0.6827. If mu is 0 and sigma is 1, then x1 is minus 1, x3 is plus 1, and a1, 2, is 0.6827 again. It is always 0.6827 for the probability of x to be in the interval mu plus, minus standard deviation. We can illustrate it in Collab 4, cell 3, as well. Similarly, the area at interval mu plus, minus 2 sigma is 0.9594, the area at interval mu plus, minus 3 sigma is 0.9973. It is called an empirical law. Problem. On average, the parts from a supplier have a mean of 31.8 inches and a standard deviation of 2.4 inches. Find the probability that a randomly selected part from this supplier will have a value between 29.4 and 34.2 inches. The answer is 0.68 because 29.4 equals 31.8-2.4 and 34.2 equals 31.8 plus 2.4. If we cannot use empirical rule, we use Book 4 or Collab 4. Example. The mean of the waste generated per person per day in the US is 4.43 pounds. The standard deviation is 1.32 pounds. What is the probability that the random person generates A, less than 6 pounds of waste per day? B, more than 6 pounds of waste per day? C, between 3.60 and 5 pounds of waste? This problem is easy to solve with the help of Book 4 or with the help of Collab 4 cells 1, 2, and 3. The answers are 0.88, 0.12, 0.40. What if we have an inverse problem where area is known and we need to find the values of x? For example, scores on a certain exam are normally distributed with a mean of 90 and standard deviation of 25. What is the score obtained by A, the bottom 10% of the students? B, the top 10% of the students? C, the middle 50% of the students? In these cases we use inverse normal distribution. It has 3 arguments, A, mu, and sigma. It returns such value of z, that the area to the left of z is equal to A, Book 4 and Collab 4, cells 4, 5, and 6, are based on the inverse normal distribution. It helps us to solve the exams. Problem. The answers are 58, 122, and from 73 to 107. The last problem in this video illustrates how find mean or sigma. Problem. 86.65% of the costs are less than $449. If the standard deviation is $36, what is the mean? Here we know the area, so we can find z using inverse function or Book 4 or Collab 3. For area equal to 0.8665, z is equal to 1.11. But z is 449 minus mu over sigma. The sigma is 36, so the mu is 409.04.